Okay, so hello everyone, welcome. Can you hear me? Hello.
Yes, sir. Yes, sir.
Okay, just we're waiting 1 minute for joining all of those other parts and then we'll start.
Okay, sir.
Meantime, so give you an announcement for our upcoming online training program. So basically, this class will be start from the 5th March, and now admission is open, and last admission date is 13 March. Okay, and if you want to join early, then you can get the 50% discount because first 10 registered people will get the 50% discount on this online training program. So basically, in this online training program, we take the class for 7 days, weekly, Friday and Saturday, and class duration 3 hours. So now we set this time, and if you want to join this online training program, you can simply contact in this WhatsApp number, as well as you can also contact with this email. Okay. So in this online training program, what you learn, you will learn all of these things from beginners to advanced level. So basically, if you have no knowledge about the coding section,
Hello, sir.
okay, so you'll start after some time. Okay, just 1 minute. Okay. No knowledge about that coding section, such as Python or JavaScript, don't worry about that. You will learn all of those things from beginners to advanced level. And here I already added all of those course content. You can easily check in the video description. Then you can easily get all of those course content. Okay. And you will also get the some benefit when you join this online training program. You can get the certificate, as well as you also get all of the slide PDF. You also get the practice code. You can all get all of those recorded class, and also get the lifetime teaching support. It's very important as a beginners, because when you want to learn the Google Earth Engine platform as a beginners, you face a lot of problem. So that's why you need the continuous support. So that's why we're also providing the lifetime teaching support regarding this online training program. Okay, if you want to join this upcoming session, which is start from the 15th March, simply contact in this WhatsApp number, also contact with this email. Then complete your registration and join in our Google Classroom and WhatsApp group. Thank you. Okay, so can you hear me? Hello.
Yes, sir.
Okay.
Yes,
So
sir.
now we'll start out to the session. Um,
Before starting the session, sir, I have two doubts
okay.
or a request
Yeah, please.
that we are having examples of we are having an example of this in DVI or time series data. Can we have some example related to agriculture or crop related examples? Can we have that?
Yeah, no problem. Okay, you also set the example. Suppose any kinds of agricultural indices. Okay, this type of things you also try. Okay. So further face any problem,
Okay.
then I also guide you. No problem. Suppose you try. Actually, in this online training program, you get the lifetime teaching support. Actually, this type of support. Suppose you want to develop any kind of model, or you want to make any kind of equation you want to calculate, but you cannot do that. Then you can get the lifetime teaching support. Okay. In this time, you just invention different types of algorithm, different types of indices, and then try to apply this type of method. Okay.
Okay. Before that, sir, are you having some codes related to crop analysis classification? Something.
Yes. We have also providing this one kind of code such as crop classification. But for the crop classification is the same, but we have also need to the ground truth data for the crop classification. Okay. And
Okay.
then we can easily do it, no problem. But when you want to learn the language land crop classification, then I also take you some guide about that how we can easily make the crop classification for the different types of crop. Okay. Then you can easily get this idea.
Okay.
Okay, we try.
Okay. Okay.
Okay, so let's go. Just I simply share my screen.
Okay. Sir.
So basically today's session I will try to discuss about that mainly how we can easily remove the cloud and haze from the satellite images for getting the very clear satellite images, as well as from Landsat and Sentinel, both of images we try to complete. And we also try to discuss about the some DEM data, mainly digital elevation model data set. It can be NASA SRTM or STAR data as a DEM, and how we can easily use the DEM data for create the hill-shape map, slope map, or aspect map, these type of things. And we also try to discuss about that land surface temperature using Landsat satellite imagery. Okay. Previous class we talked about the MODIS. In this session, I talked about the Landsat imagery, how we can easily use, and then monitor the LST. Not only for the LST, as well as also urban heat island, as well as also UFTVI index, how we can easily monitor using the LST. So these type of things I also try to complete for this session, and how to calculate average, maximum, minimum NDVI for any specific region, as well as how to make the monthly time series chart. Okay, we already discussed about that. Suppose two types of chart. One is the ready-made data set, another is the unready-made data set. But we are not complete the monthly time series chart. Sometimes when you want to work for the different types of monthly wise data, then you need the monthly time series chart. So that's why I also try to show you that how we can create the monthly time series chart. I set the example for evapotranspiration, but you can easily use this method for other types of indices, no problem. Okay, so let's go. We try to start. Then just I simply open my slide. So first of all, we talk about the LST, mainly land surface temperature monitoring using Landsat imagery. Okay, and also make the time series chart about that. So this is the study area for Dhaka city. I already make this code in here, and you can see we are also identify about the urban heat island using LST in Google Earth Engine platform, as well as we also try to develop the mainly urban thermal field variance index. It's called the UTFVI. Okay, I also send you some reference paper about that urban heat island, as well as also urban thermal field variance index. Then you can easily get the more idea about that USI or UTFVI, how it will be worked, how we can easily identify the urban heat island, as well as also urban thermal field variance index, how you can easily get this type of thing you can get. So let's go. So first of all, okay, we also try to discuss about the remove the cloud from satellite imagery. I also try to show you that how you can remove the cloudy pixel and get the very clear satellite imagery. And we'll talk about that elevation, how we can easily create the different types of data, such as NASA SRTM data, how we can easily use and then make the different types of map, hill-shape map, slope map, this type of things. Okay, so let's go. I just simply open my code editor. I want to open my data set. Suppose I want to, in this time we are work with the Landsat imagery. Mainly Landsat surface reflectance satellite imagery were used to make the monitor the LST or land surface temperature. So here you can see, suppose I am doing the Landsat 8 and the surface reflectance. Here we can easily find out the one kind of band. This band called that you can see STB10. Okay, band 10 surface temperature. Okay, so basically this band we are use and then easily monitor the LST. Okay, in this time we have used this band also, and you can see the unit is the Kelvin. Okay, and this data set have already you can see the scale and offset. Okay, so for that when I get the proper wavelength, then I must to need the reprojected. Okay, before for the modis we have already checked about the scale, modis, NDVI, modis, LST dataset. We find only for the scale, but we did not find any kind of offset. In this time, this dataset, in this time it also added the offset value also for each band. So in this time, we have also need to use the offset value also, as well as also use the scale value to reproject the scale, okay, band scale value, wavelength value. So let's go in this time. So first of all, I need to import the data set. I simply copy and then Okay, just I simply increase my font size. It's better. Okay, just paste here. So this is my image collection. I simply import and give a variable name. You can put any variable name. Suppose I put the name is that suppose image. Okay. So in this time, this is my image collection. So this image collection, I need to filter for my study area. And we already know about that, how we can easily filter. So I simply import my study area. Suppose I want to observe the LST for Dhaka city. I simply import the Dhaka city boundary. And it's imported. Default name as a table. You can put any name. I put the name, suppose RY. Okay. So now this image collection, I need to filter according to my region of interest, according to my time period, and cloud cover. So just we are using the same function. Okay. Suppose I simply put here that filter bounds function. Filter bounds function. So mainly it's intersecting with my study area, which is RY, which is stored at the Dhaka city boundary. Okay. Then further, I just simply put here filter metadata, and then I put at this, suppose cloud cover, less than 1. Okay. After that, suppose I do observe for LST year of 2023. So just I take the image for year of 2023. Suppose first January from suppose dry season. Okay. So put at year 2023. Suppose 04. Suppose 30. This time period. All of those images, I just make that it's the filter red and make the median composite. Just use here the median. Okay. And further, just click with my study area. This is RY. So now I can got my image collection. So just use here map dot add layer and call this your object, mainly image. So click to the run. Now it show a layer but not focus my study area. For that, you can simply use a function map dot center and I want to focus the shape file. So use here the RY and put the zoom level, suppose 10, and click the run. So now it's focused on my study area and it so visualize the image for year of 2023 summer season. Okay, this time period. So now I just add here the band combination. Suppose I add here the true color. And before that, here you can see it shows this type of values, very long value it show, because in this time this wave plane is not reprojected. So in this time I need to reproject it. So how I can reproject? Very easy. Just we are simply multiply this scale value. Here you can see this is the scale value, and you can see only we can get the all of those band. You can see SRB1, SRB2, all of those band is the same scale. Just we can get the different in the STB10. STB10 is the another value. Scale and also offset. Okay, so in this time I just simply use it, and when I use this band, then I again reprojected the wavelength value using this scale and offset. Okay, so in this time I just simply copy the value and then paste here. I just multiply this scale value, add with offset value. Offset value mainly you can see all of the same. So just simply copy and paste. And now just click the run and check again what happened. So now let's try to add the band combination. Suppose I just add the band combination for red, green, and blue band. Okay. So just put at that red, then put at that green, at that blue, RGB color, and then stress 98%. So now you can get that proper value, you can see. Okay. So now apply that. So now we can get this type of image, and I also want to import that and copy the visualization and further paste after the object name. Okay. Put this layer name. Suppose it's a imagery. Okay, can put anything. So now it's show the layer as imagery. So now we got our satellite images. You can see these are satellite images. In this time, we have to find out the some algorithm about that LST using Landsat imagery. So you can simply search on the Google. Suppose I search monitoring using Landsat 8. Well, I simply search and then try to okay. Suppose I try to open this flow chart. Okay, you can see this is the okay. So here you can see it's one kind of flow chart about that estimate the LST. So first of all, here you can see mainly they are take this trees data and OLI data, and from here they calculate the take the band 5 and band 4, near band and red band. Using the near band red band, they calculated the NDVI. From the NDVI, they calculated the vegetation proportion. Okay, as well as from here they take the brightness temperature, mainly thermal band, they count band 10, it collect, and they are calculated the surface humidity, and further they apply the mono window algorithm and calculate the LST. So in this time it's one kind of paper. If you want, you can also read it, then you can also get the more idea about that LST. Okay, as well as you can also, you can see this is another kind of paper. So in this paper you can get the different type of equation you can easily get from here. You can see for that you can see vegetation proportion of vegetation. This is the equation about the proportion vegetation, as well as we also get the you can see the land surface temperature. This is the equation, thermal band divided by 1 plus lambda plus a thermal band, the rho, and multiplied ln e logarithm e, and subtract with 270.15. So basically we subtract this value because I need to convert Kelvin to degree Celsius. So basically we can get the result in Kelvin, but when I subtract this value, then we can get the result in degree Celsius. Okay. So now let's check one by one. We try to complete all of those steps and then calculate the LST using that Google Earth Engine platform. So in this time, after getting this image, in this time, I need to calculate the NDVI, mainly normalized difference vegetation index. We need to calculate. So in this time, we can easily calculate the NDVI. So we already know about that, how we can easily calculate the NDVI. So for that, I just take a variable, suppose NDVI, right? And call my image and paste here, and then use a function normalized difference because it's only available for the 2 band. Okay, we can easily use this normalized difference function, and we find out the band. Mainly it's the SR B5 near infrared band, and also put here that SR B4. Okay, so put the near infrared band and red band. So now it creates the NDVI. So just I simply add the layer of NDVI band. So map dot add layer and call this object name NDVI and click the run. So now you can get the NDVI map forward study area. Okay, this it's look like that. So in this time, I want to add the visualization. Suppose click on here, and then I will custom 98% stressing, and further I set the color plated. Suppose for the low vegetation, show this type of blue color. Get at then I show this type of white color, and then I show the green color for the vegetation. Okay? I set the 3 color combination and apply. So now it create this type of NDVI map. So we can get this type of region is the vegetation. Okay. So now I just import that. Okay. Simply copy the visualization variable name and paste after the object name. So just I put here that object name and put here the layer name suppose NDVI. Okay, so now it's create the NDVI map. Okay, after that, after creating the NDVI map, we have to find out the proportion vegetation. Okay, you can see this paper. We have to find out the proportion vegetation. Okay, and what is the algorithm about, equation about the proportion vegetation? Proportion vegetation can be calculated using the following equation. It can be NDVI minus NDVI mean value divided by NDVI max value minus NDVI mean value, then whole square power 2. Okay, so in this time we are just calculate these things. So first of all, we need to calculate the NDVI mean value and NDVI max value for your study area. So in this time I already make the NDVI map. Okay, so now I want to find out what is the NDVI mean value and what is the NDVI max value for my study area. So let's go, we try to find out NDVI mean and NDVI max. That was NDVI minimum value. We calculate. So for NDVI minimum the this value, we are just take a variable. Suppose mean equal. I calculate the NDVI mean value, so I simply call the NDVI and paste here. Then use a function. This function called the reduce region. Okay. So basically, all time we are use this function to calculate the statistical value. Okay, it can be minimum, it can be maximum, it can be total, it can be standard deviation. Any kind of statistical value we can calculate from the using the reduce region function. In this time, from this map, I want to calculate it, suppose minimum NDVI value. Okay, so I just call the NDVI and then use the reduce region, and now put all of those argument one by one. So just I make a dictionary. So curly bracket start. So curly bracket. So further, you can see the reducer. Reducer, it's a keyword. This key value will be statistical value. In this time, I have to calculate the minimum. So just I put here EE dot reducer dot mean. Okay, it's called the minimum. Okay, so E reducer dot mean minimum. Suppose you need the max value, just you put here the MAX max. Okay, suppose you need the standard deviation value, just put here the STD DEV standard deviation. Then we can get the it calculated the standard deviation value from this NDVI map. I need the suppose average value, so use here the MEN mean. Then it calculated the average value of NDVI for this Dhaka City NDVI map. I have to calculate the minimum, so just use here the mean. Okay, then geometry. Geometry mainly it's your specific boundary. In this time, my specific boundary is the ROI. So just put here that ROI. Then scale. Scale is the resolution. In this time, this resolution is the 30-meter resolution. Okay. Another thing not need, I simply remove that. It's not needed this time. And now I have to print this. So just use that the print. So print this mean and click the run. So now it computed what is the minimum NDVI value for this NDVI in Dhaka City. You can see we can get the result as a dictionary. So it show the result as a dictionary. So here you can see we can get it's a minimum value of NDVI, and you can see this is the keyword is the ND keyword and key value makes the dictionary. So it's a dictionary, but in this time I cannot use the dictionary. I need to break the dictionary and then use only for this value. Okay, so for that region I just use this function. Mainly I just put here that values. Mainly in this time this values function extract the number, extract the value from this dictionary, and put a function get and put here. Okay, in this time why I put the 0, basically you can see it's only for the one keyword. Okay, and in JavaScript programming 1 refers to the 0. It calculate extract from the 0. 0 is the base. Okay, 0 refers to the first item. So further I put the 0. So in this time you can see when I click to the run, you can see it just show only for the value without dictionary. Okay, you can see it. Okay, in this time we can get the value without dictionary. Okay, just show the value. When I put the values and get 0, okay, then we can get this result. But these things I want to define as a number. Okay, because you can see in our equation we are just put here the number. We are just put here that number. NDVI mean number, and NDVI max number, NDVI mean number. So I need the number. And Google Earth Engine platform, when you define any number or when you want to construct any new number, we have to use a function. This function called ee.number. So in this time, I just simply use the function ee.number. Okay, and put this whole things in here. Just close this parenthesis. Okay, so now it worked as a number. So further, I can easily use this number and calculate it the different types of equation, such as fractional vegetation. I can easily calculate. So now click to the run. You can see we can get the number. You can see it show the number computing. Okay, because now it's work as a number. When I put the e.number, it create the number object. Okay, so now let's do the same things for the maximum. Simply copy the same code. So now try to find out the max NDVI. Paste here, and then I give the name, suppose max. Okay, and then just change in here. I put here that max. Okay, and then print the max variable. Click to the run. So now you can get the maximum NDVI value. Okay, so this is our minimum NDVI value. It's our maximum NDVI value. So now I want to apply the fractional vegetation. So I apply that fractional vegetation, or it also called the proportional vegetation. So in this time, for the fractional vegetation, here you can see this is the equation. We have to calculate this equation, mainly NDVI minus NDVI mean divided by NDVI max minus NDVI mean, then power 2. Okay, so it's very easy. We can easily calculate in our code. So just take a variable. Suppose I put the variable name is suppose FV. Now I want to calculate. So in this step, I just call the NDVI. So basically, you can say I already make the NDVI. So this is my NDVI. I simply copy the NDVI variable and paste here. Okay, NDVI mainly subtract with, sorry, it's a subtract. NDVI subtract with mean value. Mean, what is the mean? I already calculated the mean value and store it in here. Simply copy and paste. Okay, NDVI subtract with mean value, then divided by max. So call the max and then subtract with in. Okay, so in this time you can see NDVI minus mean, minimum NDVI divided by max, maximum value of NDVI minus minimum value NDVI. So we are just put this equation, and then power 2 also, power 2. So for this power 2, we are just write this code. For that, we are just use a power 2. So just use that the POW, mainly power, and power 2. It's a number. If you want, you can also use that the 2. There is no problem. But in Google Earth Engine platform, it's a cloud-based platform, so that's why all time we need to write the function, cloud-based function need to write. And in Google Earth Engine platform, when you define any new number, we have to put ee.number. It's a server function when you define any new number. So I simply use here ee.number and define my number as a 2, mainly power 2. Okay, and now I just put this name, suppose dot rename, or as I show the layer. Suppose I simply add the map dot add layer and call this FP. Click on. So now it show this fractional vegetation layer. Can get this type of fractional vegetation layer. Okay, so it's our FV or fractional vegetation, which we calculate using this equation. After that, we have to calculate it the emissivity. Emissivity in this time, here we find out some constant value. Okay, so here you can see this is the constant value, mainly 0.004. It's multiply with fractional vegetation, then add with 0.986. Okay, So you can see emissivity can be calculated by using this equation. So basically this is our equation 0.004. It's a constant value. It's multiply with the fractional vegetation and then add with 0.986. It's another constant value. So in this time we are just applying these things and calculated the emissivity. Okay, so let's go. So for that, okay, as well as I also add this name. Suppose these things I want to put a name. So I just simply put here that because this name is need, because here you can see when I click on here, it show the layer 3. Okay, there is no name. You can see it show the ND. Okay, it show the ND. But when I give a name, suppose I put this name as a, that put the rename. I put the name, suppose FV. Okay, fractional vegetation. In this time you can see when I click on this map, I can it easily showing about that FV. Okay, FV value. Mainly fraction vegetation value we can get. This type of value we can get. Okay, so just we rename it and put this name. So that's why we can easily get the name in the inspector tab. Okay, so now, okay, so now we are just calculate the emissivity. In the emissivity, we can get the two constant value. Here you can see. Okay, let me check again. One is that 0.004 and another is the 0.986. So in this time, I just use this constant value and then check it. So okay, so for that, if you want, you can just take your, okay, so I write the comment. It's a EM and take a variable. Suppose EM. For that, I just take a variable A and store it this number. Okay, so for that, it's a constant value. So EE dot number. One number is that 0.004. I take the another variable, suppose B, and store the number EE dot number and put the number. It's mainly 0.986. Okay, so it define A and B, two number. Okay, it's a constant number. So for that, we are just put the A and B in our equation. Then it will be okay. So in this time, we are just take a variable. Just I take a variable. Suppose I put the variable name as the EM. Okay, emissivity, and then I call the fractional vegetation. Mainly, it's a fractional vegetation. Okay, this fractional vegetation is multiply with 0.004. Okay, so basically it's A. So I simply copy the A and paste here. Okay, and then it add with 0.986. It is stored in the B. So simply copy the B and paste here. So now we calculated the emissivity. So now I show the layer. So just use air map dot add layer and use at the EM. Click the run. So now it displays the emissivity layer. And I also put this rename. Suppose I put this rename as a, what I put the, suppose EM. Okay, I put the rename as a EM. So now it should look like that. But when I stressing, then we are also get the better result. Suppose I just stressing, I run it again. Click here. Yes, it show the EM. Okay, because I rename it as the EM. So that's why we also get the EM also in here. Okay, but when you not put the rename function, then it show the FV default. It show the default as the first band. Okay, default as the first band. But when I rename, then it will be show which I rename. It show the same name. So now I stressing and then apply. So now we can get the emissivity layer. Okay, and if you want, you can also add the visualization. Suppose I show this type of color. Suppose for the low emissivity, we show this type of blue color. then greater than I show suppose this type of green color, greater than I show suppose this type of yellow color, greater than I want to show suppose this type of red color. Okay, so then apply. So now I can get the MCD map, we can see, and then further I import, and then copy the visualization variable name and paste after the object name the layer name as a EM. Okay, or you can put any name, no problem, as a layer name. Okay. So now in this time, after calculating emissivity, we are just in the final stage. We calculated the LST. And you can see here for the LST, we can get this type of equation. It's the TB. In this time, we talk about the TB or thermal band. Okay, it's called the satellite brightness temperature. Unit is the Kelvin. Okay, and you can see the lambda. Lambda is that lambda mainly it's the wavelength of emitted radiance, and we can get the rho value. It's a rho value constant. Okay, and we can get the emissivity range 0.97 to 0.99. Okay, so in this time we are just applying this equation. So for that I need to make the thermal band. Okay, so for the thermal band we are just take the another variable. Okay, so for that, for the thermal, yeah, I kept the thermal band, thermal. So further, I take a variable that thermal, and I just call this image. This time, it's another problem is that I put these things already. Okay, so I think it also better we are just create the another collection for the thermal because thermal band scale and offset is not same. So just I simply copy the same things, and for the thermal I create the another image collection here, and I this time I just take only for the one band. So for that I just use here multiply a thermal band. Suppose here you can see. Uh, so this is the scale. It's a so it's a scale, and then paste here, and then add with offset. Offset mainly this value 149. So simply copy and then add. Okay. And further, we are just clip our study area. So use that the clip function RY. So now I simply call this image. From this image, I just take only for the one band. So just select only for the one band, which is STB10. So you can see STB10. We can get this STB10. Okay. So now if you want, you can simply show the layer. Suppose just map.add layer. We are just add the thermal band, mainly brightness, temperature. So click to run. We can get this type of result just by simply stressing. Suppose and then further apply. So now I can get the brightness temperature, and I just simply suppose import the same default color, copy from here, and paste after the object name. And I put this layer name, suppose. Now just calculated the mainly LST. So in this time, I just use this thermal band and then calculate this equation. Basically, this or equation. Okay. So for that, just we take a variable. Suppose LST equal, call this thermal, and in this time it's a long equation. So for that we are just applying the expression method. So let's go. Just insert the expression, and first expression is that TB. Okay, so I define the letter about the TB. What is the TB? So just I put the equation, suppose TB or TB. You can put anything. TB. It's divided by, in this time, we are just simplifying. Suppose this equation, here you can see this the equation, TV divided by, we are just simplify these things. Lambda with row value, we are simply simplify these things. And we can get the value. This value is that divided by, right here, 1 plus 0.0015. It's multiply with then divided by 1.438 multiply with log emissivity. Okay, sorry, it's the emissivity. Just I put log suppose em. I put that, suppose em. In this time, this is your equation. TB divided by 1 plus 0.0115. It's multiply with TV divided by 1.438 multiply with log emissivity. Okay, so this is our equation. In this time, I just need to define about the constant value. So basically, we can get the two constant value. One is the TV, another is the EM. Okay, so now I just put this as a dictionary. So curly bracket start, and first of all, what is TV? So just we call we have to use the same. Suppose it also lowercase t. Okay, so now what is the TV? So just use the TV. So mainly TV is thermal. Okay. I already selected the STB10. Okay, in this variable I stored the thermal band TV, and further what is the EM? Okay, you can see EM. So just I try to add here the EM. And what is the EM? EM mainly emissivity. So for that, I simply call the EM layer. You can see the EM. Then paste here the EM, and then select that. I put the same layer name. You can see also EM. Okay, this is my layer name. So I simply copy the EM and also use here the EM. So now try to check this map. So just map dot add layer, map dot add layer, and call the LST. So now let's check what happened. And the mistake in here, let me check. I think some problem in the equation. Let me check. So TB one. Okay, we are just prepared this closing equation parenthesis. Okay, so now let's check. Okay, so now we can get this type of white color. So I need to stressing this result. So just click on here, and you can see it show the STB10 default. Okay, but when I rename it, suppose I just put this rename as a LST. So put here the rename as a LST. In this time it show the LST name. Otherwise it show the default first band. This first band is the thermal, so that's why it show the thermal. But in this time here you can see when I rename it, then it show the LST. Okay, so now I custom stress 98%. Okay, and in this time it's another thing is that up in this time this result show as a Kelvin unit. Okay, so I want to need the result, suppose degree Celsius. For degree Celsius we are just simply subtract this value. Okay, so how I can subtract, just I simply write the equation in here, minus 273.15. so it's a Kelvin result. This Kelvin I subtract this value, then we can get the result in degree Celsius. So now let's check. Say stressing the value also from here, suppose customer 98%. So now we can get that 28 degrees Celsius, and we get the 43.44 degrees Celsius. Okay, in our map. So in this time I set the color plated. Suppose click on the plated. Suppose low temperature, I want to show this type of blue color for the low temperature, which is less than 28 or 28. I show the blue color. Greater than, I want to show suppose this type of, okay, type of green color, and then suppose show this type of yellow color, and finally high temperature I want to show this type of red color. Okay, and further apply it, we can get this type of map for LST. Okay, so mainly okay, just I simply import this thing. Suppose just click the import and copy this visualization from here, and paste after the object name, and put the layer name LST. Now I can get the final result about the LST map, and mainly we can get that mainly urban region or build-up region, as well as also barren land. We can get the high temperature. Okay, so you can see we can get this type of things. Okay, so if you want to check the value, suppose click on here and then check what is the LST for this specific location. We can get the 43 degrees Celsius about that. Suppose you can see it's a water body. I click on here, then we can get the low temperature LST. You can get that 28 degrees Celsius. Okay, so basically this type of region we find out that the high temperature, this type of red color identify about the high temperature. Okay, so click on here, we can get this result about the 42 degrees Celsius. Okay, so basically this is the process for creating the LST map. So first of all, you simply import your image collection. Okay, and then you need to reproject the scale band value. Okay, for that we simply multiply this scale value and offset value, and we can get the image. Using this image we can just make the NDVI map. From the NDVI we find out the minimum NDVI and maximum NDVI, because these two value I need for calculating the fractional vegetation. So then we calculate the fractional vegetation, then calculate the emissivity using this equation. And first of all, we are just take the thermal band. Because basically in this time we again take the image collection, because thermal band scale and offset is not same. So that's why in this time we have take the another collection only for the thermal, and from here we select the thermal band and then find out this equation, and finally calculate the LST. Okay, so this is our LST map. So now we can easily use this map for calculate the R1 heat island map, or R1 heat island map, as well as also R1 thermal field variance index. We can easily calculate from that. Okay, so in this time I talk about that. Suppose R1 heat island, how a map can calculate using this LST map. So first of all, I will show you this algorithm. Suppose here you can see this is another paper. So basically, you can see it's called the normalized method is adopted to the compare USI due to the observed variation in LST differences within a year. So in this time, we are just use this equation. So basically, it's the normalized urban heat island. So here you can see mainly TS. TS mainly it's the LST. Okay, and TM is the average LST. Okay, and we can see the TSD. So basically, it's a standard deviation of LST. Okay, so in this time, when you find calculate this equation, first of all you have to find out the LST. We already make the LST map. Okay, and then we need to calculate the average result of LST, and also calculated that standard deviation of LST map. Okay, then we calculated the urban island, as well as also you can see the UTFVI. So basically it's the another index, mainly urban thermal field variance index. So when you calculate this index, then we are just put this type of things. Mainly TS is the LST, it's the LST minus mean LST divided by LST. Then we can get the UTFVI. Okay. So in this time, I just try to show you that how we can easily calculate this type of equation and make the urban island and also make the UTFVI. So very easy. It's so let's go. And okay. So from here, we already in this time, suppose I talk about that USI urban island. So first of all, I need to calculate it that average LST. Okay, it's need for the calculating the urban island. So just take a variable. Suppose I put the variable name is that average LST. Okay, so how I can calculate the average value? Very easy. Just we are called the LST and paste. Then use the function reduce region. Okay, we already know about this function. Basically, when you calculate any statistical value in a specific boundary, all time we are use this function reduce region. So then simply put all of those things one by one, and here I find out. I just make a dictionary. So curly bracket start, and also curly bracket int. So first of all, reducer. So in this time, reducer is a statistical function. So reducer, I put here the e dot reducer dot mean. Okay, average. Geometry, it's your specific boundary, which is RY. Scale is the resolution, which is 30 meter, and CS not as remove that. So now I just try to print that thing. Suppose I just simply print this average LST. Simply copy and paste. Okay, you can see in this time I got this number as a dictionary. Okay, I can got this number as a dictionary in the console tab. Okay, you can see it. We can get that average LST is the in Dhaka city average LST 35.94 degrees Celsius. So this is the value. Okay, and we can get the result as a dictionary. In this time, if you want, you can simply copy this value and work with that. Okay, or if you want, you can also use this variable name. Because I'll show you the two ways. Suppose in this time, I just copy this value and work with that. So in this time, also calculated that suppose standard deviation of LST in Dhaka city. So just take a variable. Suppose STD LST and call the I simply copy the same things from here and paste here. Okay, so now if you want, you can simply change it. I put that std dev, standard deviation. So now just print that std lst, simply copy and paste here. In this time it printed the what is the value about the standard deviation of LST in Dhaka city. Now we can get this type of value, 2.68 degrees Celsius. It's the standard deviation value in Dhaka city. So in this time, I find out that average LST as well as find out the standard deviation LST. Okay, and in this time we can get the result as a dictionary. You can see the dictionary. Okay, we can get this result. But I want to use this number in my equation. Okay, so for that we can simply use the same function. Suppose I just use a function, suppose values, and I want to extract only for that first, mainly 0 is the first item in this dictionary, first item, and also put here the values and call the get only for that first item. So now you can see what happened. Without dictionary, we can get the computed object. Okay, but these things I want to need as a number. Okay, so for that I simply add the function e dot number. So that's why I can easily use this number for my other equation, and also use here this e dot number and put here these things my other equation. So just I create this e dot number. In this time we can see it show the e dot number computing. Okay, so now it's work as a number. Okay, in this variable work as a number. Average LST or std LST, it's work as a number. So that's why I can easily use this variable in my equation and work with that. So let's go how it will be work. So for that I will put this equation is that mainly subtract with average LST. So I already make the average LST, simply copy and paste, and finally it will be divide. So just put here the divide with standard deviation LST, simply copy and paste here. Okay, so now further we are just add it, add layer, paste by people. So now I can get the Arvind island map.